test problems on rationalization.
I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is another test question, the real questions which you find in test papers. It is based on rationalization. Well, some of the students really get surprised when they need to rationalize the numerator also. As you can see in this question, we begin with a very simple one, then the normal one, right, which you know about, and then the bonus or the complex one. Now, it is important to understand that normally, whenever you write your answers or solutions, radical should not be there in the denominator, and therefore, we need to rationalize it by default. In many applications, we have seen that the expressions could have radicals in both numerator and denominator, and they need to be rationalized. So here is the question for you. You can always pause the video, answer this, and then look into my suggestions. Let me thank all the viewers and subscribers for watching these videos and suggesting excellent comments and remarks. So let's go through these solutions one by one. The very first one, 6 over 5 square root 3. How do we solve this? Well, that's simple. We have 6 over 5 square root 3. Now, since we do not want square root 3 in the denominator, we need to multiply and divide by the same term, which is square root 3. In the numerator, we get 6 times square root 3. And in the denominator, we get 5 times square root 3 times square root 3 is just 3. Now, some of you will like to write it like square root 9 and then get to 6 square root 3 over 5 times 3, right? Well, both are valid, but you could have gone directly also from here to this, right? So that is also possible, right? Now, it is important to write the final step in the simplified form. See, 6 can be divided by 3 2 times, correct? So if you do not do this step, then you lose 0.5 marks. So that is kind of marking scheme, right? So we have 2 square root 3 in the numerator and 5 in the denominator. We have rationalized. We do not have any radical in the denominator. Makes sense, right? Perfect. So now let's take up the second question, which is 5 over 2 square root 3, right? Now, to rationalize, we have to multiply and divide by the conjugate, right? So, what is the conjugate of denominator? So, conjugate here is 2 plus square root 3, right? And the idea is that a plus b times a minus b is always equal to a square minus b square, right? So that is the concept known to you. And now let's begin. So we have the expression given to us as 5 over 2 minus square root 3. So as you know, rationalize means multiply and divide by the conjugate, which is going to be 2 plus square root 3. Correct. So once you have done that, we know that a denominator now is difference of squares, and in the numerator, I have to multiply with 5 both the numbers, correct? So what do you get? 5 times 2, you know, is 10, so we get 10, and then plus 5 square root 3, right? So that becomes the numerator, and in the denominator, we have difference of squares, which is 4 minus square root 3 square, right? So let me rewrite like this, right? Square root 3 square, which is 3, right? So let me go one more step. So I'm doing some additional steps here, which is only to explain you the whole process, correct? So it is 4 minus 3, which is 1, and therefore I can write this as 10 plus 5 square root 3. Makes sense? Perfect. Simple as that. The last question before you is the one which is a really challenging question. Many of the students have not seen this question so far, and first time they encounter it is normally in the test paper. Perfect. So basically in this case, what we need to do is to rationalize both denominator as well as the numerator. Perfect. So it means what? It really means that this expression, which is square root 6 minus x minus 2 over square root 3 minus x minus 1, needs to be multiplied by the conjugate of the numerator, which is square root 6 minus x plus 2, right? Divide by square root 6 minus x plus 2, and also by the conjugate of the denominator, which is square root 3 minus x plus 1 over square root 3 minus x plus 1. Does it make sense to you? Have a good look at it, right? You have to rationalize both. We'll also look into the reason of doing it and how does it really help, okay? It has a connection with calculus, right? Finding limits. So, that far we are looking at while answering this particular question. Okay, great. So when you do that, what do you get? Well, in the numerator, square root 6 minus x minus 2 when multiplied by its conjugate will give us difference of squares, and that is clearly 6 minus x minus 2 square is 4, right? So that is one expression times the square root expression, which is square root 3 minus x plus 1, correct? And in the denominator, we have, now when we multiply, we have 3 minus x and minus square of 1, which is 1, times square root 6 minus x plus 2. Okay, so now it seems as if we have complicated the expression more than required, right? Let's see. How does it work? Well, 6 minus x minus 1, let us expand this. 6 minus 4 is basically 2, right? So what we get here is a term which is 2 minus x, right? And within the radical sign, we have square root 3 minus x plus 1, right? And in the denominator, what we have here is that we have multiplied square root 3 with its conjugate. 3 minus x minus 1 will give us 2 minus x, right? And in the radical, we have square root of 6 minus x, and that is plus 2, right? Perfect. So as you can see, we could now cancel 2 minus x. And therefore, we have written this in a very simplified form, which is square root of 3 minus x plus 1 over square root of 6 minus x plus 1. Do you see that? So, plus 2. Right. So even after rationalization, we do have radical in the denominator. Then how does it help us, right? That was the question, right? So see, the application here is, you will understand that if I write the value of x as approaching 2, for example, right, then what happens? Let me say that x is approaching a value 2. You will soon realize that it cannot be 2, right? Because you have this restriction here, right? When I substitute x equals to 2, then we get 0. So we have a restriction here that x is not equal to 2. So this simplification is true. However, x cannot be 2. Now if I substitute 2 here, what happens? Check. If I substitute 2, I get square root of 6 minus 2, right? Minus 2 in the numerator, and in the denominator we get square root of 3 minus 2 minus 1. And see, 6 minus 2 is 4, so square root of 4 minus 2. And here we get square root of 1 minus 1, and that is 2 minus 2. And here we have 1 minus 1, and both ways we get 0 over 0. You see now that when x approaches 2, rather when x is equal to 2, we get 0 over 0. This is called indeterminate. Now, when we have cancelled this out, we can find the value. When x approaches 2, what happens? Because in this particular expression, as you can clearly see, if I substitute 2 here, it is not going to be 0 over 0, right? So, because we have already cancelled the factor which made it 2, right? So, in calculus, we try to find the limit of the function. So, the extension here is to find the limit when x approaches 2. Of course, x cannot be 2, right? So, when you substitute 2 here now in this particular expression, what do you get? 3 minus 2 will give you 1, and 1 plus 1 will be 2. And the denominator, 4 minus 2 will give me 4, and you get 2 plus 2, which is 4, right? So, we get 2 over 4. So, we see that this expression, as x limit approaches 2, in that case, this expression approaches a value which is 2 over 4 or 1 over 2, correct? So, the limit exists. So, we know that it approaches 2, it is approaching a value which is half. That is the kind of importance of this particular process, and you will see this soon in calculus, while we understand the concept of limits. So, I hope it connects with you how this simple process of rationalization will be very helpful as we move from pre-calculus to calculus. Perfect. So, with that, we come to an end of this video. Feel free to write your comments and suggestions. In case you want to learn from me, send an email on the address given. Thanks for your time and all the best.